Welcome everybody. It's since May 5th when we first launched Atlantis Hyperscale Hyperconverged appliances. It's been quite a wild ride. We did a streaming launch from London in the Churchill War Room with more than 1,500 people watching in 53 countries. And this is really a follow-on webinar to dig a little deeper and give people information about how Hyperscale works, how they can apply it to their data center, and answer a lot of the questions that are out there about the product. So without further ado, I'll get into it. If you have any questions or want to start a conversation with me, I've listed my email, my Twitter handle, and we've been tagging all of the Hyperscale conversations with the Go Hyperscale hashtag. So feel free to start a conversation. I'll check right after the session is over. So the first thing I wanted to do was give you an analogy to explain either if you're new to hyperconverged or if you are needing to explain it to someone what the value of it is within your organization to a business owner. And really the best one I could come up with was the convergence into a smartphone of these three different distinct functional pieces of hardware. In this case, a phone, a portable music player, a camera are kind of equivalent to what we have in traditional data center with SAN, server, and network. And what we were able to do over time was not only make each of these individual components better, but bring them into a single device. And this is very similar to what we've done with hyperconvergence over the years. We've eliminated the need to buy very proprietary, expensive, unwieldy individual pieces and replaced it with an elegant integrated system through hyperconvergence. Now, one thing I wanted to do before we got too far was do a little poll and figure out, which of kind of the traditional benefits of hyperconvergence you thought were most important. So, Carol, if you could launch the poll, I'd like everyone to kind of select, what they think is most important about a hyperconverged appliance. Now, we're going to make it really tough on you and make you pick one. So what's most important out of hyperconvergence? You have, the ability to reduce costs. This was kind of the, inception of the hyperconverged appliance kind of value was to eliminate the need for shared SAN, which has dramatic cost reductions. Performance sometimes not associated with hyperconvergence and more with maybe an all-flash array type storage approach, but in some cases performance can be really critical if you're running databases. The ability to scale linearly, high availability capabilities, so there's a lot of questions and maybe apprehension about going hyperconverged without understanding what the high availability model is to protect data. And then, there's a number of other potential benefits. So I'm interested in kind of hearing what you think before I give you my opinion on what's kind of most important and what you value in hyperconvergence. So let's take a look at some of the results here. Interesting. So we have cost, so performance leading with 32%, scalability. So it's pretty well distributed across the four there. I'll take a look at the others after the fact and see what was up there. But actually, we'll look at. I have a similar poll later in the presentation that ranks high availability at the top. So we're getting a little different information from this audience. Maybe that's a result of the fact that the title included all flash or our customer base. But we'll see. But thank you for that. I'll kind of touch on each of those points as we go through the webinar. So I think a lot of people who are familiar with Atlantis as a software company have asked me a lot of questions about how is Atlantis USX or some of the older desktop virtualization software products different from Atlantis Hyperscale. And the continuing our smartphone analogy, I would compare Atlantis USX to being more like Android, right? It's a operating system, it's a platform that you can run on pretty much any hardware that writes to it and integrates with it. That has pros of being very flexible. You can pick all sorts of different configurations, hardware, and it will work. It's software. It's extremely flexible. Hyperscale, on the other hand, is very tightly integrated. It's a pre-integrated appliance that has everything deployed already. You don't have to size it. You don't have to architect it. It's simple. And there aren't a lot of variation in options. So we kind of offer both sides of the equation. So if your needs aren't met by one of the hyperscale configurations, you can use Atlantis USX. So I consider hyperscale more like an integrated iPhone, and USX more like Android. And it's not to say one is better than the other. There's a fit for both. There's pros and cons to both and reasons to use both. So we'll talk about a little bit deeper in when you might use each one. So Atlantis USX is a software-defined storage platform. So you can take it, you can pool any SAN, NAS, direct attached storage, flash, shared storage, create hybrid volumes, in-memory volumes, all sorts of stuff. And Atlantis Hyperscale is a pre-integrated all-flash appliance. So it only has one storage volume type. It's a turnkey appliance. You can have it up and running in 20 minutes from when you rack it and power it in your data center. And it's built on the same functionality and core IP of the Atlantis USX SDS platform, but it's very different in the way we approach it because it's a pre-integrated appliance that has kind of the best value hardware configuration that meets the vast majority of our customer needs built into an appliance. A couple of things I'll point out. If, let's say, there's a configuration of Hyperscale that you would like to run and you can't run it, you can always use USX and do whatever that may be. So, for example, if someone wanted to do hyperconverged on blades, you could use USX to do that. It has a hyperconverged volume type. So I wanted to make that clear, give people a good understanding of how the two things are different, and we'll dive in a little bit more. So it's important to understand that. So the first thing that's interesting and a value to the data center is we're collapsing a lot of that infrastructure. So all different kinds of storage arrays that you might have to address different types of workloads can all be replaced. The compute, the networking is all built into a single appliance, which dramatically simplifies life when you can standardize on one architecture and one modular approach to data center. Now, we have done, it is all flash, so we've been able to replace the entire spectrum of performance of storage rather than having to tier and do different types of storage for different workloads. So let me give you a quick introduction to Hyperscale before we dive into the details. So first of all, it is the only configuration available from Hyperscale is all flash. Now, a lot of people ask me, why'd you do that? Why don't you do a hybrid model and an all flash model? Well, the reason is that with the Atlantis data reduction capabilities, which are very efficient, the incremental cost of making it all flash was negligible. So if you can have all flash everywhere and have it cheaper than you expect a hybrid or SAN, disk-based SAN to be, why not go all flash is kind of the conclusion we came to. You don't have to pick and choose. It's simpler. All the applications in your data center can get all flash performance. Pricing, we were put a lot of focus on trying to drive down the price of the appliance as low as we could. And we did this both by leveraging our technology really well, our data reduction capabilities, as well as doing creative things with our supply chain to pull cost out of the equation. And the result is, as a customer, you get tremendous performance and compute specs for a very low cost, starting at $78,000. And that number will vary based on the hardware platform and some of the options, but you'll see that it'll be somewhere typically between 50 and 75% cheaper than comparable hyperconverged systems, or not comparable because they're mostly hybrid, but what you would compare as the most common hyperconverged systems. So you're really getting kind of from a price performance value perspective, this is really unprecedented in the hyperconverged space. You've got a lot of people who have delivered hybrid architectures that are, in my opinion, very overpriced. You've got people who have announced or demoed all flash capabilities, but they cost, near $1 million and are not economically viable. So this is really the first kind of economically viable all-flash hyperconverged platform. And we'll talk about why we can do that when others have not been able to. The other thing that's fairly unique about Hyperscale is the freedom to choose a wide variety of server and hypervisor platforms. So the appliance is available on 4 different server platforms, Cisco, HP, Lenovo, and Supermicro, as well as 2 different hypervisors, VMware and Citrix, and we'll be continually expanding that hypervisor list as the product evolves, and also adding to the server platforms as customers want different configurations. So in summary, at a high level, you're getting all-flash performance. We'll talk a little bit more about cost, and we developed a tool to help you kind of understand, your particular comparison. But as I said, it's going to be well over 50% cheaper than either your traditional storage and compute bought separately, or the other hyperconverged platforms you might be looking at. You get the freedom of choice to deploy and avoid being locked into one vendor, either on the hyperconverged hardware side or on the hypervisor. And then you'll get the trait of modular scalability. So with each individual appliance, you basically have an all-flash array worth of storage built in to that appliance, and that scales out modularly, so you can add appliances as needed to get more compute and storage. So we just touched on this. I think one of the kind of inherent attributes of hyperconverged in general that's really changes how people operate in the data center is that you can scale out as you need it. You don't have to buy big SAN controllers in advance and plan 18 months out for capacity planning. You can just add appliances as needed, and that will save you money over the long run. Besides the cost per terabyte or cost per unit of compute being lower, it allows you to scale in smaller chunks and be more linear in how you scale. Okay, one big change in how we operate that came with Hyperscale was how we do support for Hyperscale. So with the Atlantis USX software, we're supporting our software. Of course, we help customers deal with problems that relate to the compute and hypervisor. But with Hyperscale, we're actually taking responsibility for the support for the whole appliance. So if you have a disk fail, a disk that fails in your appliance, or a power supply, or an issue with the hypervisor, Atlantis will help you resolve that. You don't have to go to 3 different vendors to solve that problem. Now, the other part of that that's really interesting is that we're also backed by the parts networks of the server vendors on which you buy the appliance. So you get kind of the best of both worlds. You have a specialized hyperconverged vendor who understands the whole stack, helping you solve problems. You have someone who knows the space really well, and can deal with everything from a disk failure to a storage volume issue. And then we have a global parts network to back that up, which is in line with how you already service and maintain your server platforms. Okay, so let's talk a little bit about functionality. Those of you who are familiar with USX, the capabilities are, from a storage perspective, are very similar, except it's much more tightly integrated with the compute. So it's pre-integrated with the virtualization platform, so either vSphere or XenServer. We've constrained the type of storage volumes and pre-integrated that as all flash volumes, as opposed to, USX can pool lots of different things. The data services are the same between USX and Hyperscale, so this isn't a new product. We've got a very proven storage platform that is integrated into this, that has been deployed to 52 petabytes of storage, 1,000 enterprise customers. So it's a solid platform. We excel in data reduction and I/O acceleration data services, but also include kind of standard things like thin provisioning, tiering, fast metadata cloning, and can present different types of storage with the platform. The management allows you to create volumes that have, these are pre-created in the case of Hyperscale. In the case of USX, you can create different types of volumes. And you have an API that allows us to write integrations to different platforms for driving, monitoring or health status of the system, or in some cases creating storage volumes independently. So just a quick look, there's a simple management interface. I just thought I'd give you a peek at this. We have demos online where you can get into the details of the management system. This is the front screen. It shows the kind of high availability status of all the components of the system, from the file system to the networking to the service VMs, and how high availability is laid out. Provides some simple storage management functions that allow you to drive things like cloning or movement of a VM from one volume to another within or between data centers. And it always, data reduction is a key part of the whole platform that allows you to both add performance and get more storage capacity out of the system. So the latency and deduplication and data reduction rates are always front and center in the platform. It also provides analytics across the compute and storage components. So you'll see things like CPU utilization, IOPS, offload, dedupe rates over time in the analytics section. So one thing I wanted to highlight here is that the way in which Atlantis does data reduction is significantly different than other hyperconverged platforms you may be familiar with. So the way it works, and we have some videos on the I/O flow that you can reference if you want to get into more detail. But in general, it takes metadata, and as I/O comes in, we're processing and making very fast decisions on blocks in memory, which allows us to eliminate a large percentage of the I/O before it has to traverse the network and be written to the underlying flash. So it's not just all flash, but it's a very efficient all-flash architecture that eliminates a lot of the networking bottlenecks that can become a problem in hyperconverged when you're not doing any data reduction at the ingest of the I/O. This allows us to have both more IOPS, lower latency, better throughput, than a system where you're writing 100% of the blocks down to a tier. And it also means that data reduction is more effective because we don't have to have the hardware to write the blocks because we've handled it in memory on the wire as it's coming in. We don't have to destage down to a tier of physical storage. These are patented technologies. These have been in production for a long time. They integrate with our high availability and data protection in a way that keeps, that eliminates the possibility of data loss or downtime from a single node failure, which we'll touch on in a minute. Now, if you compare this to some of the other vendors in the hyperconverged space, you have Nutanix, which writes to a flash tier. That means that both they need additional hardware. Also, if the blocks need to be destaged down to a hard drive, that introduces latency latency and performance degradation, and ultimately the amount of hardware that you can take out of the system while providing the same amount of effective capacity, it requires more hardware, which means more cost. Simplicity has a card, a dedicated card to do this, which means that there's both an increased cost there, and they suffer from the same kind of performance challenges. Once you exceed the cache of that card, you're going to overflow to disk and run at disk speed, and that creates performance challenges. Then you have EvoRail, which has no data reduction, which means that once you apply data protection, with a single node failure equivalent on a 4-host cluster, you're cutting the capacity in half, which means that your cost per gigabyte is doubling. So the lack of data reduction really makes it even more expensive than just buying traditional compute and storage independently. So let's give you a little more detail on under the covers on what's running on the appliance. So each appliance is a 4-node system with 2-socket servers on each node. There are VMs that are on each node that create a storage system. So we have 3 400 gig SSDs. We'll go into the specs a little more in detail in a minute. And we have very high-end compute, so Haswell processors times 2 for each node, so 96 cores total. It's configurable between 256 and 512 gigs of RAM per node, so that's 1 to 2 terabytes per appliance. Has a hypervisor and 10 gig networking built in. So we have a concept called service VMs, which are responsible for pooling the storage between the 4 hosts. And then we have volumes, which create storage volumes for data that run on the various hosts, and we have configured it to have HA enabled, so that if a host goes down where there's volume running, the HA volume takes over for that host. And then the effective storage capacity ends up, there's 2 models, one with 12 and one with 24. The 400 gig SSDs is the 12, and 800 gig SSDs for the 24. In terms of high availability and resiliency, if you look at the service VMs versus the volumes, any one either software component like a VM or node or disk can fail, and the shared storage between the 4 continues to operate. So it has that built into the 12 and 24 terabyte models when you fire it up in your data center. Okay, server platforms. So as I mentioned before, there are 4, HP, Cisco, Lenovo, and Supermicro. The Supermicro has the Atlantis branded bezel on the front there. Let me just give you a little visibility into what the underlying components are. So the HP, Cisco, and Lenovo are the 1U times 4. So DL360, C220, and X3550. And then the Supermicro is the Supermicro Twin Pro, which is in a 2U form factor. These, again, just to reiterate, those of you who are, USX, experts and have worked with that in the past, the Hyperscale has very fixed configurations. So we'll get into what those are in a minute, but we don't deviate from the bill of materials of the appliance. It's very fixed configurations. If you want to do something custom, you can always do that with the Atlantis USX software. Just to give you a little more detail on the specs, we have spec sheets on the website for each of the 4 appliances, but they're pretty standardized across the 4, other than the models and form factors in terms of the number of U. So there'll be E5-2680V3 processors, with 96 cores total. The memory on the 12 can range from 256 to 512 per host, or in the 24 can be 384 to 512 per host. The 12 model has 3 400 gig SSDs, and the 24 model has 3 800 gig SSDs per node. And the 12 and 24 terabytes is the effective capacity based on a guaranteed 70% deduplication or data reduction rate. So that's the amount of storage available to the applications with a 70% deduplication rate, which we see kind of typical mixed workloads, mixed VM workloads being more like 80% or 5-to-1. You know, VDI being more in the kind of 10-to-1 range. So, you know, we picked a conservative number there to give people and guaranteed it to give people the amount of capacity that they should expect to get. Now, one of the things I wanted to just, you know, there are a lot of questions after the launch about this. Hugo Fan, a colleague of mine, wrote a blog on it, but I thought this was good to show people so they understand the math behind the 12 and 24 terabytes. So it's 4 nodes, 1.2 terabytes of flash per node, which means each appliance has 4.8 terabytes. The data reduction that we do basically consumes some of that space, about 25%, and you get down to 3.6 terabytes of available raw capacity, basically, for that's usable for the file system. On top of that, we have a dedupe rate guaranteed of 70%, and there's a storage guarantee document on the website. The only caveats to that are workloads that we know won't deduplicate well, like video compression, encrypted data, so forth. And then that'll result in a 12 terabyte if you, you know, when you achieve the 70%. Now, the nice part about this is if you do a workload and you get 80%, you're actually getting 18 terabytes of effective capacity. Or if, let's say, you do VDI and you get 90%, you're getting 36 terabytes of effective capacity. That's all bonus and free, and we're not going to charge you extra for that. Okay, so let's talk about applications and workloads. So Hyperscale is a general purpose, you know, hyper-converged appliance. You can run any workload you want on it. But I thought I'd give you some exposure to what we see customers gravitating towards for kind of really sweet spot workloads. Database is one of those. We're in the process of publishing a database reference architecture, but we already had Howard Marks did a test with the database recently that's on our website if you want to look at that. We also have customers using it for Exchange, so we're going to fire up a reference architecture and benchmark test of that shortly. One of the most common ones is general VM, server VM storage, like mixed, you know, Linux, Windows server VMs. That's very common. Analytics is another one. Anything that requires, you know, high I/O storage performance and you know, runs virtualized is basically a good workload for Hyperscale. And then, of course, near and dear to our heart is VDI, which is, you know, in the early days of Atlantis is where we started and made our name. So let me give you a few details here. There's a demo on our site that has this iometer test. So this is one Hyperscale appliance doing 160,000 IOPS at 0.6 milliseconds latency. The configurations listed there: 50-50 read-write, 4K block, 80% random, one Hyperscale appliance. So that's pretty impressive, in line with, you know, what a all-flash array of the same size would be able to do. This is a customer. I wanted to share this because it gives you an idea of the relative savings. This is a customer who had a 250 terabyte database estate that they wanted to move from disk-based storage. We did a business case with them, and the interesting part was we looked at both doing USX fronting their shared storage, which is the red. The black is using their existing disk-based storage, which was a SAM. And the green is the hyperconverged approach, which ended up being about, in this case, it was 73% cheaper over the 5-year period. And this is just the actual hardware cost, not factoring in a bunch of OpEx, OpEx soft cost factors. This is the hardware cost itself and what it costs to run it and maintain it. So, just as a relative, the point I would take from this slide is that, the hyperconverged appliance in particular can result in tremendous cost savings. And more, I'd say most of our people who have looked at the SDS platform have used it as a way to migrate from SAN and NAS to a hyperconverged platform when they've used the software, and the ultimate goal when they look at the economics of it is to go all hyperconverged, all flash tends to be the end result of all the analysis. So, kind of hyperscale is the end goal of most of that data center transformation work we've done with USX predating hyperscale. This is a preview from the upcoming database reference architecture. This was on a single hyperscale 4-node appliance. And what you can see here is that the transactions per minute is on the vertical axis, and the horizontal axis is the increasing number of users in the HammerDB benchmark test, which represents transactional database. So as we increase the number of users, the number of transactions increased linearly, and we got to the point where we were at about 320,000. So if you look at the cost of a appliance that this was run on in the kind of $80,000 ballpark, you're talking 24-25 cents per transaction, which is ridiculously cheap. So that gives you an idea of the power of it in the database context. And we'll be publishing full reference architecture. You can look at all the configurations and specifications. VDI, I've been doing kind of VDI reference architectures and things for a long time. This is really the lowest cost per desktop and performance that I've seen. This was from the XenDesktop reference architecture published in early May at about the time of the launch. If you're familiar with login VSI charts, this is an exceptional one. We're doing 608 users on one 4-node appliance with performance that's averaging the 1089 VSI max average, which is tremendous. And we're not even pushing this to the limit. We peaked out at 92% CPU with an average of 53%. So this, there was another webinar on this done by a colleague, Patrick Brennan, where he went through all the economics and everything in the context of VDI, and it's roughly $128 per seat, including 3 years of support. So this is a tremendous VDI platform, but that's not all it does. So now, cost, if I remember correctly, was second to performance in our poll. In this recent report, which was great, by the way, I thought it was very well done by hyperconverge.org and Scott Lowe. Other than high availability, and this is why I was commenting the juxtaposition, high availability ranked lowest on our poll, but highest on this one. But in either way, cost is the second, cost/ROI is the second. So I think one of the things we made a point of was during the launch was to be very transparent about our pricing and costs, and a lot of people wrote about that in the market. So I wanted to be a little audacious. Let's talk about costs. Let's put the numbers out there. If competitors want to debate the numbers, we're happy to debate them, but let's have an open and transparent conversation about the cost of these things instead of platitudes about, oh, we're going to save you 40 to 60% without providing any detail or information on against what or for what or in what situation. So let me give you, this is kind of the high level, what we showed in the launch. I have a lot of detail behind this, but we basically built that in to a tool. So if you take on the left side, you have kind of typical 4-node hyper-converged hybrid appliance. We're about 75% cheaper than that list price to list price. Now, compared to traditional compute, it's even more dramatic, 85%. I don't even want to show you the numbers against an all-flash hyper-converged array. Those are scary. But what we did was we created, and it's still kind of in beta, we're adding to it, but we created a tool that you can go to that's on, if you go to atlantiscomputing.com and you go to the Hyperscale page, it's in there. And you can pick a CX12 or a CX24 and compare against some of the other vendors. And we're adding all the sources that we used for this into little information bubbles so you can do your own calculation. We'll also be adding kind of an advanced option so that you can enter your own cost for whatever you're comparing against. But interested to get your feedback on this. It's a beta, so something might need to be fixed. We could have a bug in it. Let us know. We want to just have this conversation, give people a way to compare how hyperscale can change the cost equation in their data centers. Okay, so in the title we promised kind of 5 ways that we would revolutionize the data center. So here's my 5 ways. One, it's going to simplify things a lot. You're going to consolidate a lot of hardware. You're not going to have specialized networking. It's all commodity x86 hardware that's very nicely integrated into a smartphone-like package that makes it very easy for you to grow your compute and storage in tandem and deliver tremendous performance to your applications. 2, cost reduction. So I encourage you to compare what hyperscale can do compared to what you're doing today or what you're thinking about doing, whether that's traditional compute or you already have some hyperconverged deployed, but maybe you haven't taken over the whole data center with it yet. Reevaluate. These are new cost levels, new levels of efficiency that haven't been out there before. So I really encourage you to take a look at it. All flash performance. We've had hyperconverged as a market growing really fast. We've had all flash arrays as a market growing really fast, but they've been limited in their use because they haven't come together. If you look at the applications that are run on all flash arrays, it's still a minuscule part of the overall storage capacity that's out there, and you have to pick and choose carefully which workloads you use it for because it's expensive. And then hyperconverged, conversely, often has performance challenges. While vendors can show lots of benchmarks with millions of IOPS, we all know when you get it into the lab and you run real workload on it that is bigger than the cache of those systems, that it crumbles. So this is really the first time that we've brought together kind of the benefits of both of those categories into one appliance, and that makes it easier from a planning perspective. It makes it something that you can standardize on one platform across the whole data center. Freedom to choose your servers and hypervisors. As a vendor and someone who's seen a lot of negotiations, having the option to go between 2 hypervisors and to go between multiple server vendors is something that'll have dramatic cost reduction, whether you're as opposed to being locked into one or the other. We're giving you that freedom. So if you're take the hyperscale approach and you start on one server platform and another one kind of emerges as the lower cost one, you can combine them, you can switch. It's very easy. If you're trying to maintain a dual vendor hypervisor strategy, we can support that also. And that's really going to be the way to drive down cost the most. That's the point if you trade, if you subscribe to the approach of standardization and commoditization as a way to drive down costs, you shouldn't accept being locked into a single server platform or hypervisor in order to get hyperconverged. And then scalability. So I think, operationally, it's much easier to scale this way, and there's tremendous benefits all across the data center from that, especially when you can do it at the price point that we're talking about here. Okay, with that, I wanted to, Carol's going to launch another poll. You can kind of self-select whether you want to, get some more information or, get a quote. One tool that I wanted to point out that's useful on our website is if you go to the Hyperscale and then the Buy Now page, one thing I didn't mention is that Hyperscale is sold exclusively through our channel partners. So you can't come to Atlantis and buy a Hyperscale box. You go through a channel partner. And we've set up, answer 3 questions: which server platform, what capacity, and which hypervisor you want, and actually 4 questions, and your region, so US, UK, usually it's by country or state. And then it'll give you the partners that are offering it in that state. If you don't, see your preferred partner, let us know, and we're happy to work with them to set them up to sell Hyperscale. So with that, we'll give you a couple more seconds to kind of finish out that poll and how you want, if you want to see any follow-up. What I would do now is ask you to enter questions into the questions box, and I'd be happy to answer them with the remaining time we have in the hour. And if we don't get to your specific question, we can follow up after the webinar. So, and while we're see the questions coming in, let me start with a couple of kind of common questions that might come up. So we kind of tried to address them. There's so questions about the whole effective capacity. I think we touched on that a little bit, but data reduction is core to how we do everything, as opposed to some of the other vendors who have data reduction capabilities that you turn on or off because they either slow the system down or consume more resource. It's inherent in the whole system and how Hyperscale works. So, we thought it was appropriate to base that on effective capacity rather that you can get for the applications. So we did have a question come in about scalability, which is how do you scale? In the current release of Hyperscale, we scale per appliance. So you would add additional appliances to scale. In an upcoming release that we'll be doing, we'll be adding the capability to scale per node. So that will give it a little more granular scalability in the upcoming release. Okay, so let me, feel free to type in more questions. I think, oh, here we go. Does Hyperscale push agent VMs to my servers? So Hyperscale does have VMs that are pre-installed on the appliance when you get it. So it doesn't push any VMs to your server. You get them, and the VMs are all pre-configured in the appliance and laid out in a way to present the storage that's required for the appliance. So there's nothing you need to do other than input like networking information and accept a license at the beginning to get the storage up and running. And you don't need to have, it'll show you the VMs. You can see them in whichever hypervisor you're using that we have deployed, but you don't need to manually configure or do anything to those VMs. Okay. There's one question about They didn't see a comparison to other types of storage, NetApp, Vmax, reliability, flexibility, cost. We'll do some more work on that and publish some blogs, but essentially, and you can look at the cost compared to traditional storage in the cost comparison tool that I mentioned. So from a reliability standpoint, the way that the appliance works is that it's designed to be able to have one node completely fail and have the storage continue operating and then bring that back up and have the full functionality. Obviously, you lose the compute resource of that node if it's down, but that's the same with any other hyper-converged system. Flexibility-wise, Hyperscale is designed to be kind of a fixed configuration. You can do everything you could do previously with the hypervisor. From a flexibility standpoint, DRS, HA, between the VMs, any of that, vMotion, all of that works. What was the last one? Oh, and cost. You can look at the cost comparison tool. And I'm happy to have more detailed conversations on cost comparisons. I think when we add the functionality where you can input your own costs, per gigabyte and so forth, that'll be useful in that cost comparison tool. Okay, good question. And actually, this is important to note: is the hypervisor license, in this case, he asked about vSphere, included? No, the hypervisor license is not included, but a trial license comes with the appliance when you receive it, and then you apply your own vSphere license, or our channel partner can bundle a vSphere license with it and have it and integrate it at your site in terms of applying the license. So that's how we do it. Because there's a choice of hypervisor, and some people have their own ELAs or have already purchased hypervisor licenses, it doesn't make sense to, by default, force people to buy the hypervisor. Let's see. So is Hyperscale fully compatible with infrastructure monitoring tools like VMware Operation Management to see health, risk, and capacity? So if you use vSphere, you have all of the capabilities that come with vSphere and can connect to that. So that is still on the system. It's not deprecated or constrained or in any way. So anything that you could do with that hypervisor independent of Hyperscale can be done on the Hyperscale appliance, including VMware Operations Management. Another note is that in the upcoming release, we are going to have vVol support, so that you can leverage the functionality of vVol with both USX and Hyperscale. Okay, so another question is, with no Hyperscale VMs on my servers, does that mean that Hyperscale is less efficient than a pure USX deployment that would do dedupe on local USX VMs before updating the data on the HA USX appliance? So no would be the short answer. It's kind of a long question, but the Hyperscale, again, comes pre-configured with all the VMs you need. It's the same platform and functionality as USX, so in terms of the efficiency of it, it will be the same as USX if USX were deployed in the same configuration from an efficiency standpoint. And HA is pre-configured to have well, first of all, there's a data protection so that, any one of the nodes can fail. And then HA is configured across the volume so that any of the nodes that have a volume on it could fail, and the HA volume on a secondary node would take over. Okay, just looking at if there's any other questions? Okay, looks like a follow-up question from Bruce. So no Atlantis VMs run on my production servers. No, all of the Atlantis infrastructure runs on the appliance itself. So we don't need any additional compute resource to run any of the components of Atlantis Hyperscale. Okay, let's see if there's any last questions before we wrap this up. I think we answered everything. So with that, Carol, if you have any parting thoughts, I'll let you wrap it up. And I believe you'll get an automated email that has a recording of the session, and encourage you to visit the atlantiscomputing.com/hyperscale kind of microsite page that has all of the information and resources, spec sheets, data sheets, cost comparison tools, webinars on different topics. And we look forward to, this is just the first in the line of many more kind of deeper dive webinars that we'll do on Hyperscale itself.